All right, let's just jump right in. We're living in a time where artificial intelligence isn't just learning how to think, it's learning how to see. And you know what? What it's seeing is completely changing the game, how we understand our world, from a single street to, well, the entire globe. And this quote here from Gavin Baum-Blake at City Detect, it absolutely nails it. We're talking about a brand new kind of vision, a way to spot problems almost the second they pop up.
So what does that new vision look like in the real world? It looks like this number, 3,000. That's how many piles of storm debris an AI system spotted in just 1 week after a hurricane. Insane, right? So how on earth does it work?
To get it, we need to start with a real-world crisis, because this isn't some sci-fi movie. This is happening for real, right in the middle of the chaos after a disaster hits.
Okay, so picture this. Greenville, South Carolina, just got hammered by Hurricane Helene. I mean, streets are blocked, homes are damaged. Emergency managers are staring down this just colossal cleanup job. The scale of it is almost impossible to wrap your head around.
So that's the big question, right? How do you even begin to assess all that damage, figure out what to clean up first, and get help where it's needed most, all before things get even worse? Doing it the old way, by hand? That would take weeks, maybe longer.
And this is where things get really clever. Enter City Detect. These guys had a brilliant idea. They thought, what if we put smart cameras on the vehicles that are already driving around the city every single day? You know, trash trucks, street sweepers. Their AI just constantly scans the streets, automatically spotting, cataloging, and mapping everything. It's incredible.
And the result in Greenville? The AI didn't just find those 3,000 debris piles. No, it also mapped out over 1,200 miles of damage collection routes. I mean, that's a level of speed and precision that was just pure fantasy a few years ago.
So that's what it can do, but how does the AI actually see this stuff? To get that, we've got to pull back the curtain a little bit and look at the core tech making it all happen.
The secret sauce is this concept called embeddings. Now, it sounds super complicated, but just think of it like this. An embedding takes something complex, like a photo of a downed tree, and turns it into a unique numerical fingerprint. It's a fingerprint that captures the essence of that image in a language a computer can instantly understand.
The whole process is actually pretty elegant. It all starts when a camera on a truck snaps a picture. Then, boom, the AI transforms that image into an embedding, that digital fingerprint we just talked about. And finally, the system compares that new fingerprint to millions of others it's already seen, says, yep, that's storm debris, and instantly plots its exact location on a map, all in a flash. So City Detect used this tech to map a city in crisis, which is amazing. But what if we started to think bigger? What if we took this exact same idea and just scaled it way, way up?
What we just saw with City Detect, that's like the AI version of mapping a single neighborhood. It's a lifesaver for a city for sure, but it's still pretty local.
But what happens when you apply that same logic to the entire globe? Well, that's where this whole thing gets truly mind-blowing.
And this isn't just a what if. A project by Cloudflare and the European Space Agency is doing it right now. They've created the world's first global embeddings dataset by pointing this AI tech at satellite imagery, mapping the entire surface of the Earth at a crazy detailed 10-meter resolution.
So what can you do with a map like that? I mean, what can't you do? You can track climate patterns in real time, watch cities grow, monitor natural disasters as they unfold. You can even predict crop yields for entire continents. It's this incredibly powerful new lens for understanding our planet. But here's the catch. When you create a tool that's this good at seeing the real world, you also, by accident, create a tool that's really good at creating fake worlds. This all-seeing eye can be a powerful force for truth, but it can also be a heck of a tool for deception. It's really a double-edged sword, isn't it? On one hand, you have a tool for truth, real-time maps that guide first responders to save lives. But on the other hand, the exact same tech can be used for chaos, generating deepfakes, spreading panic, and pumping out misinformation right when people are most vulnerable. And this isn't just a scary thought. It's already happened. During the California wildfires, someone used AI to create these super convincing fake images of the Hollywood sign burning down. They went viral, and it caused actual real-world panic, overwhelming 911 with false reports. So how in the world do we fight back against that? Well, the pros are developing new playbooks, like this multi-step verification process you see here.
It's this really rigorous system of checking sources, using deepfake detectors, and cross-referencing with experts. It's basically about creating a human-led firewall to separate the facts from AI-fueled fiction.
So, with this constant tug of war between truth and deception, where does this technology even go from here? What does this all-seeing future really look like? Well, one of the biggest moves right now is toward openness. See, for years, all the different satellite companies use their own weird, disjointed data formats. The solution is to create standardized, open formats for everyone. Think of it like creating a universal plug for satellite data. The goal is to get this powerful information into more hands so more people can build useful tools with it. And if you think what we've seen so far is impressive, the next leap forward could be something else entirely. We're talking about quantum computing. Now, the power we're talking about here is just staggering. Your computer uses bits that are either a 1 or a 0. Quantum computers use qubits, which can be a 1, a 0, or somehow both at the same time. This unlocks a level of processing power that is exponentially faster than anything we have today. It could supercharge these AI mapping systems beyond what we can even imagine right now.
And that really brings us to the final, most important question. We are building an all-seeing eye. It's capable of mapping and understanding our world in real time with detail we've never had before. The technology is here. The question isn't, can we do it anymore? The question is, what will we choose to do with this incredible power? How are we going to use it?